Again, if you don't want to be on the video, please make sure that you cut your cameras off, okay? All right, I'm going to go ahead and share my screen. Okay, move this out the way. All right, good people. This is where we are. We're in EOG review number 7. Okay, I want you to click on this. All right. Please make sure that you watch this video after we have completed our session today. I need you to watch this video, part 1 video. Okay, but I'm going to go ahead and open this up. And we're going to do this first, and then I want you to watch that video. Okay, let's pull this up. And make sure put it in there right. It's still twisting and turning. I don't know what it's doing. It's just turning, spinning, spinning, spinning. I'm gonna pause my screen for a minute and make sure that everything is good. Okay. Give me 1 second. Okay, it does come up. So it is there. It's just not coming up on my screen. Let's try it again. It's out the way. Link it again. All right, there it goes. Okay, so you have this pulled up. Make sure I got all the pages. Yes, babe. Can you what now? You can say continue, please. Thank you. All right, and I need to print this back page because I did not print that page earlier. Let's see. What page is that back page? Admit some more folks. It is page 4. Yes, babe. Does what now? Good question. I don't know. It's just going to depend because different sessions are going to end at different times depending on when they actually get started. So roughly, yes. Is it precise? No, because it's just going to depend on the session. And extended time, because some folks get an additional amount of time and all this stuff. So roughly, yes. All right, so I am going to let that print. I'm gonna go ahead and get started. Okay, guys, let's look at this. Our EOG review number 7. We're gonna go over some things in the calculator, but before we do that, we're gonna talk about systems of equations first. A system is more than one, okay? So anytime you're talking about like a school system or bus system, body system, it's more than one of something. So a system of equations is more than one equation, okay? It's more than one equation. The x and y in both equations have the same meaning. The x and y in both equations, or in all equations really that's in the system, have the same meaning. So that means if the x in one of the equations is the number of hours, then the X in the other equation also is the number of hours. If the Y is the total amount of money made in one of the equations, then the Y in the other equation is also the total amount of money made. So the X in both equations have the same meaning. The Y in both equations have the same meaning. What does it mean to solve a system of linear equations? To solve a system of linear equations means that you're finding all the points that the equations share. Okay. To solve a system of linear equations, or any equations for that matter, is to find all the points, if they have any points, that they share. And we can say points are ordered pairs that they share. So all the points that they share is the solution to the system. All the points that they share is going to be the solution to the system. Okay? All the points that they share is the solution to the system. There are 3 types of solutions. Okay, so let's draw a little coordinate plane in each of these. We're going to label this as my x-axis. This is my y-axis. Let me put arrows at the end. Hey, Miss Moore. Good morning. Good morning. Okay, so to solve a system of linear equations, you have 3 different types of solutions. You have where when you graph the ordered pairs, they share 1 point. That means they cross at one location. So this is one solution. It's one solution, which means they cross. Let me plug this up real quickly. That means they share one point. This is the point that they share. So this is the solution. Wherever they cross, or however many points they share, that's going to be the solution. So this system of equations has one solution, okay? All right. So let's look at another type, okay? If they never cross each other, which means that the lines are parallel, they have the same slope, they never cross each other, this is no solution. So parallel lines do not share any points. This is a no solution. No points shared. This is a no solution because they don't share any points. One solution, that means they only share 1 point. No solution, that means they don't share any points. Okay? They don't share any points. The third type of solution with straight lines is that they happen to graph they're right on top of each other. That means they graph the same line. So these lines are right on top of each other. This is infinitely many solutions because they share all the same points. Lines are on top of each other. They graph the same line, okay? They share all the same points. This is infinitely many solutions. Infinitely many solutions, because they share all the same points. They share all their points. infinitely many solutions. When they graph the exact same line, they share all the same points. Okay. Any questions about that? All right. I see a couple people still writing, so I'm going to pause for the calls, okay? Can you make copies of this last page? 'Cause I forgot to do that. Probably like 25. Okay. All right. So now let's go to the word problems. Okay. Make sure that you have your calculator available. Is there anyone that's still writing, needs me to wait a second? Jonathan, make sure you focus, okay? All right. Okay, so let's look at this. A large pizza place costs $6.80 plus 90 cents for each topping. The cost of the large cheese pizza at the other pizza place is $7.30 plus 65 cents for each topping. How many toppings are needed to be added to a large cheese pizza from the first place and the second place in order for the pizzas to cost the same? So you want to know, when do they cost the same? At what point can you order the exact same number of toppings and you get the same price for both? So let's write the equation for both. Let's start off with the first pizza place. Let's write the equation. This is a linear equation because we have a constant rate of change. We have a constant rate. They're charging 90 cents for each topping and a starting amount. You automatically have to pay the $6.80. So my rate, my M, is 90 cents because it's 90 cents for every single topping. My starting amount, the amount I automatically have to pay, is the $6.80. Remember, when you're writing linear equations, you write them in slope-intercept form. That's y equals mx plus b, where again, m is your rate and b is your y-intercept, okay? So the equation for the first pizza place is going to be y is equal to, my rate is 90 cents x, okay? So it's 90 cents per topping. Remember, y is on the top, x is on the bottom all the time. So since it's 90 cents, cost is on the top, cost per topping. So the meaning for y is your total cost. The meaning for x is your number of toppings. Okay. All right. So x is your number of toppings, and y is your total cost, plus $6.80. So this is your first equation. Your second equation for the second pizza place, your M, your rate is going to be 65 cents per topping. And your starting amount is going to be the $7.30. Okay, $7.30. So to write this as an equation using slope-intercept form, which is y equals mx plus b, you're going to replace M this time with 65 cents per topping, and B with the starting amount of $7.30. So y is equal to 65 cents times the number of toppings plus a starting amount of $7.30. Now we're going to use our calculator to figure out when are they going to be the same amount. So in our calculator, we have X, which is the top number of toppings. And we're going to look at your first pizza place and then your second pizza place. Okay. All right, so let's clear our calculator. Second plus 712. Second plus 712. So now we're going to type in this first equation. Go to y equals to type in your equations. This is 90 cent 0.90. X is right here beside the green alpha button. Plus $6.80. All right, so we're going to type in the second equation. That's the first pizza place. This is the second pizza place. 65 cents. So that's 0.65. X is right beside the green alpha button. Plus the $7.30. So we typed in both equations. Now we want to look at the function table so we can compare the total amounts. So to view your function table, you press the second button and graph. Second graph will give you this function table. So let's look at this. With 0 toppings, your starting cost is $6.80 for the first pizza place and $7.30 for the second. And we knew that already. These are our starting amounts. Okay. With 1 topping, look, the price is not the same yet. Look, 2 toppings, look, the price is the same at 2 toppings. It's $8.60. So at 2 toppings, that's when your price is going to be the same. So look at this. All right. It tells you right here. Okay, so at 2 toppings, how many toppings? 2 toppings. Price is $8.60 at both pizza places, at both places. Okay, so this is your answer here. It's $2.0860. This is when they are the same. And don't forget to type in the equations. You go to y equals, it's here. To view the function table, you press second graph, and this is where you compare the tables. See a couple people still writing. Raise your hand if you're in the classroom and you're still writing. Okay, a couple people. If you're at home, use the raise your hand tool if you're still writing. So I'll know. Okay, so we just got 1 person in classroom. All right, cool beans. Let me know when you're finished, babe. Oh, okay. Thank you.
Can you go back up real quick?
Sure. Is that good, babe?
Yes, ma'am.
Okay. Let me know when you're finished, okay?
I'm done.
Okay. You're done? Okay. All All right, I'm gonna keep moving. Is there anybody else that's still copying? Are you still copying, Gregory? Okay. So yeah, they probably. Gregory? Okay. All right, let's go to the next one. It says Mrs. Kitts worked at a music store. Last week she sold 6 more than 3 times the number of CDs that she sold this week. Okay. Mrs. Kitts sold a total, look at this, a total of 110 CDs over 2 weeks. Which system of equations can you, okay, so we're going to write the system of equations. So let's look at this one. Let's look and see what we can figure out. Last week, so we're talking about last week, let's do L is equal to, she sold 6 more than, so that's 6 plus 3 times the number of CDs that she sold this week. So that's 3 times this week. Let's do T. Okay. So last week, this week. So let's do L represents last week and T represent this week. These are our unknowns, okay? Okay, so this is number of CDs last week, number of CDs this week. And I should have put number of CDs. Sorry, y'all. It says Mrs. Kitts sold a total of 110 CDs over 2 weeks. So the last week amount, L, plus this week amount, T, is equal to 110 CDs. Okay. So these are the 2 equations here. And this is what they want you to write. This is your answer here. Okay. If I wanted to solve for these, okay, I don't think they're going to ask you to solve for these. I'll do it anyway, but I don't think that they're going to actually do that on your test. But let's solve it anyway, just in case. All right, so this is, we're going to plug this in for L. So we got L, and I did it backwards, L for some reason. We got L plus T is equal to 110. L is 6 plus 3T, and bring down the plus T. Okay. So now we're going to combine like terms. I don't even really need these parentheses. So when I combine 3T plus 1T, that's 4T. So this is 6 plus 4T is equal to 1T. So now I'm going to subtract 6 on both sides. So I have 110 minus 6, which gives me 104. I'm going to divide both sides by 4. So I have 104 divided by 4, and that gives me 26. So T is equal to 26. So T is this week. So this week there were 26 CDs that were sold this week. So to figure out last week, we're just going to plug 26 into the equation. So this is last week is equal to 6 plus 3 times this week, which is 26. So this is, let me type this in, 6 plus 3 times 26, and that's 84. So last week, 84 CDs were sold. This is this week. This is last week. Okay. And I think only thing they're going to ask you to do is just write the equation. Raise your hand if you're at home and you're still writing. Okay, couple people. If you're coming in late, please make sure that you do not leave class until I have corrected attendance, because you're late. You were I already took attendance at the beginning, so you were marked absent. But if you leave without me knowing, I'm not going to know that you were present. Okay, so please don't leave until attendance has been corrected.
And here I am.
It's okay. It's okay. All right. Anyone else still copying? Okay. I know it's all good. It's okay. It's okay. It's all right. Okay. All right. So the next one, it says the length of the rectangle. So we got your length of your rectangle. Let's draw a rectangle. And so this length right here is L is equal to triple the width. So that's 3 times whatever the width is. So that's 3W. Okay. And remember, this right here is your width. So we're going to put W right here. Which system can be used to find the dimension? So all we're doing is just writing what the system is going to be, what the equation is going to be. And so which system of equations to find the dimensions, find the length and the width, okay, of the rectangle if the perimeter is 86. So they want you to use perimeter. Remember, to find the perimeter, all you're doing is P is equal to, you have your length, you add all these sides together. So that's going to be width plus length plus length. Or you can write it as, let me put or you can write it as 2W plus 2L. So this is one of the equations, okay? The other equation is going to be, you see right here where it says your length is equal to 3W. So these two are your equations that you can use to figure out, oh, and perimeter is 86. I forgot to put 86 here. Okay, so these are the two equations that are used to find the dimensions. Is there anyone that's still writing? Okay, a couple people. Okay. It says the Frosty Ice Cream Shop sells sundaes for $2 and banana splits for $3. On a hot summer day, the shop sold 8 more sundaes than banana splits and made $158. Okay, so all we're doing is writing the system for this. Okay, so let's keep in mind this is how much the sundaes cost, and this is how much the banana splits cost. What is it that we don't know? We don't know how many sundaes were sold, and we don't know how many banana splits were sold. So we're going to use X for sundaes equals number of sundaes and Y is the number of banana splits sold. These are our two things that we don't know. All right, so on a hot summer day, the shop sold 8 more sundaes than banana splits. So we got banana splits is Y. Oh, sorry. So we got sundaes is X is equal to 8 more. It sells 8 more. So it's 8 plus the number of banana splits. Okay. So whatever, if they sold 2 banana splits, then you're going to say 2 plus 8. That's how many sundaes were sold because they sold 8 more sundaes than they did banana splits. Now this is the total amount that's made. Okay, so this is one of the equations. So the other equation is going to look like this. You're going to say $2 for sundaes, so that's going to be 2x plus $3 for banana splits. That's going to be 3 times y is equal to a total amount of $156. Okay, and we had to use the $2 and $3 because this is money right here. It's going to be $2 for every single sundae that's sold and $3 for every single banana split that's sold. So these are your two equations. Okay. Anyone still writing? All right, so let's look at this one. Now we're solving by graphing. So we're going to graph these. Remember, when you graph, you're trying to find out where they cross each other or if they cross at all. So those of you that forgot how to graph a linear equation, please pay attention. Okay, let's do this together. Remember, when you're graphing, the equation should be written in y equals mx plus b, where m is your slope and b is your y-intercept. Your slope, you need to write as a fraction, rise over run. Remember, your rise is your up and down, and your run is left to right. Your y-intercept, or your b, is where the line crosses the y-axis, where a line crosses y-axis. Okay. So first thing that we're going to do is label our m and b. Our m here is this number that's in front. This is -5 over 3. This is our rise. This is our run. Our b for this first equation is a +3. So we're going to graph it first, okay? So to graph this, I'm going to find b on the y-axis. That's where the line crosses the y-axis. +3 is up, 1, 2, 3. It's right here on the y. your point there. Now you're going to use your slope to put other points on the line. This is -5, so that means you go down 5 and to the right 3. Okay, so go down 1, 2, 3, 4, 5, and to the right 1, 2, 3. Try to do it again. 1, 2, 3. I don't have enough space. Okay, and here, if I want to go backwards, instead of going down 5, I go up 5. Instead of going to the right 3, go to the left 3, and I don't have enough space here. Okay, so this is my line. Oops. Sorry, y'all. All right, so let me make sure I draw a straight line. You okay, babe? So let's do the second one. My M is 1/3. This is my rise. This is my run. And my B is -3. So I'm going to find -3 on the y-axis. -3 on the y-axis is right here. And my rise is 1, so I'm going to go up 1 and to the right 3. So go up 1 and to the right, 1, 2, 3. Up 1 and to the right, 1, 2, not enough space. If I want points in the opposite direction, instead of going up 1, go down 1. Instead of going to the right 3, go to the left, 1, 2, 3. I'm gonna. So the point in which they cross each other, which is right here, is the solution. So the solution here is +1, 2, 3, and -1, 2. Okay. Oops, sorry, y'all. This is my solution. Okay. Guys, at any time you can stop and ask questions, okay? Number 2. Again, we're going to label our M and our B. Our M here is 4. So we write 4 as a fraction. If it's not already a fraction, put a 1 under it. This is my rise. This is my run. And my B is this +3. So now I'm going to graph this. I'm going to find B on the y-axis. This is where the line crosses the y-axis. B on the y-axis is right here. 3 is right here. +3. Now I'm going to use my slope. I'm going to go up 4 and to the right 1. So 1, 2, I don't have enough space. So if I don't have enough space, I got to do this backwards. Instead of going up 4, I go down 4. 1, 2, 3, 4. Instead of going to the right 1, go to the left 1. This is 1. Do it again. 1, 2, 3, 4, and to the left 1. If I don't have enough space, I put points in the opposite direction. Notice how this slope is positive. The line is going up. My M here, the number in front of X is a -1. I write -1 as a fraction by putting a 1 under it. This is my rise. This is my run. And my B in this second equation is -2. So now I'm going to find -2 on the y-axis. -2 on the y-axis is right here. Okay. Now I'm going to use the slope. Okay, so that's -1, that's down 1 and to the right 1. So down 1, right 1, down 1, right 1, down 1, right 1. I want points in the opposite direction. So instead of going down 1, go up 1. Instead of going to the right 1, go to the left 1. Up 1, left 1. Up 1, left 1. So you run out of space. Connect your points. The solution is going to be where the two lines cross. They cross right here. So this is going to be -1 and -1. This is your solution. That's the one point that they share. Okay. I want you to do number 3 on your own, and I'm going to do number 4. Number 4 looks a little different. You have y is equal to -1. That just means that you're going to find -1 on the y-axis. -1 on the y-axis is right here. And you're going to draw a line through the y-axis. This is how you graph y is equal to -1. That means the line has to go through the y-axis.
Did I miss anyone stapling the back page on this packet?
If it's x is equal to, that means the line goes through the x-axis. Since it's just y is equal to, the line goes through the y-axis. So now let's graph this second one here. M, the number attached to x, that's -5 on the top and +2 on the bottom. This is your rise, this is your run. B is +4. So that means you're going to find 4 on the y-axis, which is right here. And you're going to go down 5 and to the right 2. So go down 1, 2, 3, 4, 5, and to the right 1, 2. Go down 1, 2, 3, 4, not enough space. So where they cross is right here. So this is going to be the solution right here. This is +1, 2, and down 1. So it's -1. This is my solution. Okay, any questions, comments, or concerns? Okay, I want you to do the other two on your own. Number 5 and number 6, I want you to do this on your own. And tomorrow I'm going to go over how to do these in your calculator, okay? Tomorrow I will go over how to do these in your calculator. So I want you to do 5 and 6 on your own and submit this assignment. Don't forget about 3, number 3, 5, and 6, and submit this assignment. Any questions, comments, or concerns? Please submit this assignment today. I'm going to go ahead and stop the video. Okay.